All right, yesterday we spent time learning how to write formulas from names for ionic compounds and how to write names if given formulas for ionic compounds. Today what we're going to be doing is we're going to be taking our notes in day 5. So you'll notice that we've skipped day 4. Yesterday we copied notes from day 1, we talked about notes in day 2, we talked about notes in day 3, and you did the worksheet 2 and the worksheet 3 for homework last night. Today we're going to be skipping day 4 and moving on to day 5. We're going to be talking about molecular compounds. So the first thing you need to remember is that covalently bonded molecules are made up of nonmetals only. So when we talk about molecular compounds, we're talking about compounds that are made exclusively of nonmetals. We're going to need to use prefixes to name these compounds. So we need to know that we use the prefix mono if we're talking about 1, di means 2, tri 3, tetra 4, think tetrahedral, or trigonal planar, remember? Penta means 5, hexa 6, hepta 7, octa 8, nona 9, and deca 10. All right, there's only 2 rules when we're naming molecular compounds. Very simple. First of all, we're going to use these prefixes to tell us how many of each element is in one molecule. And we're going to use the ending "ide" for the second element. Once you have all these notes, pause the video, get your notes, and then we're going to look at the bottom of the page. All right, so we're going to name N2O4. First of all, we know this is a molecular compound because nitrogen and oxygen are both nonmetals. These are covalently bonded. All right, we have 2 nitrogens. If I look back up here, the prefix for 2 is di. So I'm going to write di, and then I'm going to write the full name of the first nonmetal. So dinitrogen. Now I'm going to look at the second nonmetal, 4 oxygens. Prefix for 4 is tetra. So I'm going to write tetra oxide. Dinitrogen, tetraoxide. And that is the name for that compound. All right, we have a little bit of a difference when our first element has only one molecule. So notice up here, the prefix for 1 is mono. So we might think we would write monocarbon and then monooxide to show 1 carbon, 1 oxygen. But in fact, if our first element only has 1 atom, we leave off the prefix mono and we just put the name of the first element. So the first element is carbon, but then we need to use the prefix mono for the second element, so monooxide. But monooxide is a little bit bulky, and so we drop the second O and just call it monoxide. So carbon monoxide. So the rule is if there is only one of the first element, of the first element, do not write mono. All right, let's do the last one here. SiO2. Si is silicon. There's only one silicon, so we're not going to write mono in front. We're just going to write the name of the first element. And then we look at the second element. We have 2 oxygens, so we're going to use the prefix di and call it dioxide. All right, now we want to be able to go the other way. We want to be able to write the name if we're given the formula, but down here we want to be able to write the formula if we're given the name. So we're going to use the prefixes to determine the subscripts. All right, let's look at the first one. Trisulfur hexafluoride. All right, tri means 3, so 3 sulfurs. So in a formula, 3 sulfurs would look like that. Hexafluoride. Fluoride comes from the element fluorine. Hexa means 6, so it's telling us that we have 6 fluorines. Notice our note over here, do not reduce the subscripts. So you might say, well, why? Since there's a 3 and a 6 here, can I not reduce this to SF3? Because that's the same ratio. Doesn't work that way with covalent compounds. With covalent compounds, we use the numbers and do not reduce. All right, let's look at the second one, carbon pentaoxide. Carbon and oxygen are both nonmetals. Carbon has no prefix in front of it. What that tells us is that there's only one carbon. Because if there's only one on the first element, we don't have to use the mono prefix. But for the second element, pentaoxide tells us we have 5 oxygens. The last one here, tetraphosphorus, tells us we have 4 phosphorus. Dioxide tells us we have 2 oxygens. That is all the notes for day 5. Now we're going to practice. You're going to do the worksheet number 5, which is naming and formula writing for molecules, worksheet number 5. So there are, 26 that you're going to write the formulas for. And then on the back, there are 14 that you're going to name.